NFPA 70 standard for electrical safety in the workplace is the primary standard in the United States that addresses electrical safety in the workplace, including hot work. NFPA 70 allows live work, including hot work, provided that firstly, a job safety analysis (JSA) is performed to identify potential hazards and establish safe work practices. Secondly, personal protective equipment (PPE) is worn, including insulated gloves, protective clothing, and a hard hat. Thirdly, tools and equipment are properly rated and insulated for the voltage level being worked on. Fourthly, the work area is adequately illuminated and free from clutter. Fifthly, a qualified observer, also known as a spotter, is present to monitor the work and provide assistance if needed. And sixthly, the energy source is verified to be off before making any electrical connections or disconnections. Hot work is generally prohibited on overhead lines or exposed conductors of voltages above 50 volts, circuits with unknown or unverified energy sources, and areas where there is a risk of fire or explosion. Additional considerations include the employer developing and implementing a written safety program that addresses electrical safety, including hot work. Employees who perform hot work must be trained and qualified in accordance with NFPA 70. The workplace must be inspected to ensure compliance with safety regulations. NFPA 70 is a voluntary standard, but it is often incorporated into state or local electrical codes. Non-compliance with NFPA 70 can result in citations, fines, or other penalties. The US regulations as outlined in NFPA 70 are similar to the UK IEE regulations in terms of the strict guidelines and precautions required for hot work. Both standards emphasize the importance of risk assessment, proper PPE, and qualified observers. However, the specific requirements and enforcement mechanisms may vary between the two countries. When discussing hot work, it's crucial to understand the specific requirements outlined in NFPA 70. This standard provides a comprehensive framework for ensuring electrical safety in the workplace, particularly when dealing with energized equipment. Firstly, performing a job safety analysis, or JSA, is paramount. This analysis involves identifying potential hazards associated with the task at hand and establishing safe work practices to mitigate those risks. It's a proactive approach to ensure that all possible dangers are recognized and addressed before work begins. Secondly, the use of appropriate personal protective equipment, or PPE, is non-negotiable. This includes insulated gloves to protect against electrical shock, protective clothing to shield the body from potential arc flash hazards, and a hard hat for head protection. The specific type of PPE required will depend on the voltage level and potential hazards present. Thirdly, it's essential to use tools and equipment that are properly rated and insulated for the voltage level being worked on. This ensures that the tools themselves do not become a source of electrical hazard. Regular inspection and maintenance of these tools are also crucial to maintain their integrity. Fourthly, the work area must be adequately illuminated to allow for clear visibility and reduce the risk of accidental contact with energized parts. Additionally, the area should be free from clutter to prevent tripping hazards and ensure easy access to equipment. Fifthly, having a qualified observer, or spotter, present is a critical safety measure. This individual's sole responsibility is to monitor the work being performed and provide assistance if needed. They should be trained to recognize potential hazards and know how to respond in an emergency. Sixthly, before commencing any work, it's imperative to verify that the energy source has been energized and properly locked out or tagged out. This ensures that the circuit cannot be accidentally re-energized while work is in progress. However, in situations where de-energizing is not feasible, strict adherence to live work procedures is essential. NFPA 70 also outlines specific areas where hot work is generally prohibited. This includes overhead lines or exposed conductors at voltages above 50 volts, as these present a significant risk of electrocution. It also includes circuits with unknown or unverified energy sources, as working on such circuits is inherently dangerous due to the lack of information about potential hazards. Furthermore, hot work is prohibited in areas where there is a risk of fire or explosion, as the presence of energized equipment could ignite flammable materials. In addition to these guidelines, there are several other important considerations for employers and employees. The employer must develop and implement a written safety program that addresses electrical safety, including hot work procedures. This program should outline the specific steps to be taken to ensure the safety of employees working on or near energized equipment. Employees who perform hot work must be trained and qualified in accordance with NFPA 70E. This training should cover topics such as hazard recognition, safe work practices, and the proper use of PPE. The workplace must be regularly inspected to ensure compliance with safety regulations. This includes verifying that equipment is properly maintained, that employees are following safe work practices, and that the overall work environment is safe. While NFPA 70E is a voluntary standard, it is often incorporated into state or local electrical codes, making it a legal requirement in many jurisdictions. Non-compliance with NFPA 70E can result in citations, fines, or other penalties from regulatory agencies such as the Occupational Safety and Health Administration (OSHA). Comparing US regulations to UK IEE regulations, there are many similarities in terms of the strict guidelines and precautions required for hot work. Both standards emphasize the importance of risk assessment, proper PPE, and qualified observers. However, the specific requirements and enforcement mechanisms may vary between the two countries. For example, the UK IEE regulations may have more specific requirements for the training and certification of electricians who perform hot work. It's important to note that NFPA 70E is not a static document. It is regularly updated to reflect changes in technology, best practices, and industry experience. Therefore, it's essential to stay current with the latest edition of the standard to ensure that your electrical safety program is up to date and effective. In summary, NFPA 70E provides a comprehensive framework for ensuring electrical safety in the workplace, particularly when dealing with hot work. By following the guidelines and precautions outlined in this standard, employers and employees can significantly reduce the risk of electrical accidents and injuries. Remember, electrical safety is everyone's responsibility. Understanding and adhering to NFPA 70E is crucial for creating a safe and healthy work environment. When working with electricity, always prioritize safety and follow established procedures. If you are unsure about any aspect of electrical work, consult with a qualified electrician or safety professional. Electricity is a powerful force that can be dangerous if not handled properly. By taking the necessary precautions and following established safety standards, you can protect yourself and others from electrical hazards. Remember to always de-energize equipment whenever possible before performing any work. If de-energizing is not feasible, follow strict live work procedures and use appropriate PPE. Never take shortcuts or compromise on safety when working with electricity. Your life and the lives of others depend on it. It's also important to remember that electrical safety is an ongoing process. It requires continuous training, education, and vigilance. Stay informed about the latest safety standards and best practices, and always be aware of the potential hazards in your work environment. By making electrical safety a top priority, you can create a safer and more productive workplace for everyone. Finally, remember that NFPA 70E is just one piece of the puzzle when it comes to electrical safety. It's important to also comply with other applicable codes and standards such as the National Electrical Code, NEC, and any state or local regulations. By taking a holistic approach to electrical safety, you can create a comprehensive program that protects employees from all potential hazards. For example, the NEC provides detailed requirements for the installation and maintenance of electrical equipment. Following these requirements is essential for ensuring that electrical systems are safe and reliable. Similarly, state and local regulations may have additional requirements that are specific to your jurisdiction. It's important to be aware of these requirements and comply with them accordingly. By following all applicable codes and standards, you can create a robust electrical safety program that protects employees from a wide range of hazards. In addition to NFPA 70E, the Occupational Safety and Health Administration (OSHA) also has regulations related to electrical safety. These regulations cover a wide range of topics, including lockout/tagout procedures, personal protective equipment, and training requirements. Employers are required to comply with OSHA's electrical safety regulations to protect their employees from electrical hazards. OSHA also conducts inspections of workplaces to ensure compliance with its regulations. If a violation is found, OSHA may issue citations and fines. Therefore, it's important for employers to be familiar with OSHA's electrical safety regulations and to take steps to comply with them. There are many resources available to help employers and employees learn about electrical safety. These resources include training courses, publications, and websites. By taking advantage of these resources, you can increase your knowledge of electrical safety and create a safer work environment. The Electrical Safety Foundation International (ESFI) is a non-profit organization that provides educational resources and training programs on electrical safety. ESFI also conducts research on electrical hazards and promotes electrical safety awareness. The National Safety Council (NSC) is another organization that provides resources and training on workplace safety, including electrical safety. The NSC also offers a variety of safety certifications. By utilizing these resources and staying informed about electrical safety, you can help prevent electrical accidents and injuries in the workplace. Remember, electrical safety is a shared responsibility. By working together, we can create a safer and more productive work environment for everyone. Hot work on electrical systems presents significant risks, and strict adherence to safety protocols is paramount to prevent accidents and injuries. Firstly, understanding the definition of hot work is crucial. It refers to any work performed on electrical equipment that is energized or has not been properly de-energized and locked out or tagged out. This includes tasks such as testing, troubleshooting, repairs, and maintenance. Given the inherent dangers of working with live electricity, it is essential to minimize hot work whenever possible. Before undertaking any electrical task, the first step should always be to de-energize the equipment and verify that it is in a zero-energy state. This involves disconnecting the power source, locking out the circuit breaker or disconnect switch, and tagging it to prevent accidental re-energization. Only when it is impossible to de-energize the equipment should hot work be considered, and even then, it must be approached with extreme caution and meticulous planning. Secondly, a comprehensive risk assessment must be conducted before commencing any hot work. This assessment should identify all potential hazards associated with the task, such as electric shock, arc flash, arc blast, and thermal burns. The likelihood and severity of each hazard should be evaluated, and appropriate control measures should be implemented to mitigate the risks. The risk assessment should be documented and reviewed by all personnel involved in the hot work. Thirdly, a written hot work permit should be required for all hot work activities. This permit should outline the specific tasks to be performed, the hazards involved, the control measures to be implemented, and the personnel authorized to perform the work. The permit should be reviewed and approved by a qualified supervisor or engineer before work begins. Fourthly, only qualified and trained personnel should be allowed to perform hot work. These individuals should have a thorough understanding of electrical safety principles, hazard recognition, and the use of appropriate personal protective equipment (PPE). They should also be familiar with the specific equipment and procedures involved in the hot work task. Fifthly, the appropriate PPE must be worn at all times during hot work. This includes arc-rated clothing, insulated gloves, safety glasses or face shield, and hearing protection. The PPE should be selected based on the potential arc flash hazard level, as determined by the risk assessment. Sixthly, insulated tools and equipment should be used for all hot work activities. These tools should be specifically designed and rated for the voltage level being worked on. They should be inspected regularly for damage and defects and replaced as needed. Seventhly, a qualified observer, also known as a spotter, should be present during all hot work activities. The observer's sole responsibility is to monitor the work and provide assistance if needed. They should be trained to recognize potential hazards and know how to respond in an emergency. Eighthly, a clear and unobstructed work area should be maintained during hot work. All unnecessary materials and equipment should be removed from the area to minimize the risk of tripping or accidental contact with energized parts. Ninthly, proper lighting should be provided to ensure adequate visibility during hot work. This is especially important when working in confined spaces or areas with poor lighting conditions. Tenthly, emergency procedures should be in place and readily available in case of an accident or injury. This includes having a first aid kit, fire extinguisher, and emergency contact information readily accessible. All personnel involved in the hot work should be familiar with these procedures. Finally, regular safety audits and inspections should be conducted to ensure compliance with hot work procedures. These audits should identify any potential hazards or deficiencies and ensure that corrective actions are taken promptly. By implementing these safety measures, the risks associated with hot work can be significantly reduced. However, it is important to remember that hot work should always be considered a last resort, and every effort should be made to energize equipment before performing any electrical task. In addition to the above measures, it is also important to consider the following when planning and performing hot work. Firstly, communication is key. All personnel involved in the hot work should be informed of the potential hazards and the control measures being implemented. Regular communication should be maintained throughout the task to ensure that everyone is aware of the situation and any changes that may occur. Secondly, coordination with other trades or departments is essential. If other work is being performed in the area, it is important to coordinate the activities to avoid any potential conflicts or hazards. Thirdly, proper grounding and bonding should be maintained to minimize the risk of electric shock. All equipment and tools should be properly grounded, and bonding connections should be inspected to ensure their integrity. Fourthly, the use of ground fault circuit interrupters, GFCIs, should be considered to provide additional protection against electric shock. GFCIs can detect small leakage currents and quickly de-energize the circuit, preventing serious injury. Fifthly, lockout/tagout procedures should be strictly followed to prevent accidental re-energization of the equipment. These procedures should include the use of locks, tags, and a documented process for de-energizing and re-energizing the equipment. Sixthly, the use of voltage-rated matting or blanket should be considered to provide additional insulation and protection from ground faults. These materials should be placed under the worker and around the equipment to create a safe working zone. Seventhly, the weather conditions should be taken into account when performing hot work outdoors. Rain, snow, or high humidity can increase the risk of electric shock. Hot work should be postponed or cancelled if weather conditions are unfavorable. Eighthly, the potential for arc flash should be carefully evaluated. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. It can produce intense heat, pressure, and noise, causing severe burns, injuries, and even death. The arc flash hazard level should be determined using appropriate calculations or software, and the appropriate PPE should be selected accordingly. Ninthly, the use of remote operating tools or devices should be considered to minimize the need for direct contact with energized equipment. These tools can allow workers to perform tasks from a safe distance, reducing the risk of electric shock or arc flash. Tenthly, regular training and refresher courses should be provided to all personnel involved in hot work. This training should cover the latest safety standards, procedures, and best practices. It should also include hands-on training on the use of PPE and insulated tools. By incorporating these additional considerations into the hot work process, the risks can be further reduced and the safety of workers can be enhanced. Remember, electrical safety is a continuous process that requires constant vigilance and attention to detail. Always prioritize safety and never take shortcuts when working with electricity.